Meteorology is the scientific study of the Earth's atmosphere, including the processes and phenomena that govern weather patterns, climate, and atmospheric dynamics. Meteorologists analyze atmospheric conditions, weather systems, and climate trends to forecast weather, understand climate variability, and study the impacts of weather and climate on society and the environment. Here's how meteorology studies weather patterns and climate. Atmospheric composition and structure. Meteorology investigates the composition, structure, and properties of the Earth's atmosphere, which consists of layers of gases surrounding the planet. Atmospheric science studies the distribution of gases, aerosols, and pollutants in the atmosphere, as well as vertical temperature and pressure gradients, atmospheric stability, and atmospheric circulation patterns. Weather observation and measurement. Meteorology collects and analyzes weather data from various sources, including weather stations, satellites, radar, weather balloons, and buoys. Meteorological observations measure parameters such as temperature, humidity, air pressure, wind speed and direction, precipitation, cloud cover, and atmospheric composition, providing essential information for weather forecasting and climate monitoring. Weather forecasting. Meteorology predicts future weather conditions by analyzing atmospheric data, numerical weather models, and statistical techniques. Weather forecasters use computer models to simulate atmospheric processes, generate weather predictions, and issue forecasts for specific regions and time periods. Short-term weather forecasts predict weather conditions up to a few days in advance, while long-range forecasts project weather trends over weeks to months. Weather systems and phenomena. Meteorology studies the dynamics of weather systems, including high and low pressure systems, fronts, cyclones, anticyclones, thunderstorms, tornadoes, hurricanes, blizzards, and other atmospheric phenomena. Meteorologists analyze the formation, movement, intensity, and behavior of weather systems to understand their impact on local and regional weather patterns. Climate analysis and modeling. Meteorology investigates climate variability and change by analyzing historical climate data, long-term climate trends, and climate models. Climate scientists study factors such as greenhouse gas concentrations, solar radiation, ocean circulation, land surface characteristics, and atmospheric circulation patterns to understand the drivers of climate variability and project future climate scenarios. Climate classification and regional climate variations. Meteorology classifies and maps global climate patterns based on factors such as temperature, precipitation, and vegetation. Climate classification systems, such as the Köppen climate classification, categorize regions into distinct climate types, such as tropical, temperate, arid, and polar climates. Meteorologists study regional climate variations and anomalies, such as El Niño and La Niña events, to understand their impacts on weather patterns and climate variability. Climate change impacts and adaptation. Meteorology assesses the impacts of climate change on ecosystems, societies, economies, and infrastructure. Climate scientists study the effects of global warming, sea level rise, extreme weather events, and shifts in precipitation patterns on agriculture, water resources, public health, biodiversity, and coastal areas. Meteorologists also develop strategies for climate adaptation and mitigation to minimize the risks and impacts of climate change. Applied meteorology. Meteorology applies scientific knowledge and techniques to address practical challenges related to weather forecasting, aviation, agriculture, energy, transportation, emergency management, and environmental protection. Applied meteorologists work in fields such as aviation meteorology, agricultural meteorology, renewable energy forecasting, disaster risk reduction, and air quality management to provide weather-related services and support decision-making in various sectors. Overall, meteorology studies weather patterns and climate by analyzing atmospheric processes, collecting observational data, developing predictive models, and studying the interactions between the atmosphere, oceans, land, and biosphere. By advancing our understanding of weather and climate, meteorology helps society prepare for and respond to weather-related hazards, plan for climate resilience, and make informed decisions about environmental management and resource allocation.